Mini lesson 2E, trigonometric ratios. Here we have a right triangle. We have theta and the opposite of theta, the longest side, the hypotenuse, and then the third side next to it is the adjacent. The sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Cosecant of theta is hypotenuse over opposite. Secant of theta is hypotenuse over adjacent. And cotangent of theta is adjacent over hypotenuse. One way to remember the first three trig functions is SOHCAHTOA. Let's review simplifying square roots. To simplify the square root of 60, you want to try to pull out perfect squares. The most common perfect squares to take out is 4, 9, 25, and 49. If you can't take out one or more of these perfect squares, the square root is most likely already simplified, but not always. 60 is divisible by 4, so we could have 4 times 15 equals 60. The square root of 4 is 2, and 15 does not have any other perfect squares in it, so we just leave it as square root 15. This is our simplified square root. For square root of 63, we cannot divide by 4 or we'll get a decimal, but we can divide by 9. 9 times 7 gives you 63. The square root of 9 is 3. 7 is a prime number, so it doesn't have any more perfect squares. Rationalizing the denominator. Often when you find an answer, it will have a whole number in the denominator and the square root will go to the top. That's usually a standard notation for these types of answers. So what we want to do is rationalize these denominators. We simplified these square roots before from the previous example, so let's go ahead and fill those in. We have 8 over 2 square root 15. We can simplify this fraction by dividing both by 2. Then we have 4 over the square root of 15. To rationalize this denominator, we're going to multiply the numerator and the denominator by the square root of 15. That causes the denominator's square roots to cancel out. You're just left with 15 in the denominator. In the numerator, we have 4 square root 15. And this would be our rationalized expression. On the next one, 12 over square root 63, let's rewrite it with the simplified square root. 12 divided by 3 is 4. So we have 4 over square root 7, rationalize, multiply by the unity fraction square root 7 over square root 7, and then you get 4 square root 7 over 7. You can't simplify this anymore, so this is your simplified expression, your rationalized denominator. Now that we have reviewed how to simplify, let's go ahead and find some trig ratios here. We have the square root of 60 again, so let's change that back to the 2 square root 15. And then let's refer to the top where it says sine is opposite over hypotenuse. Well, first of all, let's figure out what the reference angle is. In this case, it's A. The opposite of that side would be 2. The longest side is hypotenuse, and then the third side is adjacent. Using those, we could write out sine is opposite over hypotenuse, 2 over 8, and that reduces to 1 over 4. Cosine of A is adjacent over hypotenuse, so that is 2 square root 15 over 8. That reduces to square root 15 over 4. Tangent is opposite over adjacent, 2 over 2 square root 15. This needs to be rationalized. Multiply square root 15 over square root 15. And then you get the square root of 15 over 15. Cosecant of A is the reciprocal of sine. That's 4. Secant of A is the reciprocal of cosine. 4 over square root 15. That needs to be rationalized. We have 4 square root 15 over 15. Cotangent of A is the reciprocal of tangent. So we just have square root 15. We can use this unrationalized fraction from before. Now to find the approximate angle measure, we can use any of these trig functions to evaluate for that. Let's just use sine. So what we want to do is find arc sine of 1/4. Let's go ahead and put those into the calculator. When you get to the calculator, go to the toolbar and make sure that it is in degrees first. Type in arc sine parentheses 1 over 4, and it gives you about 14.5 degrees. And then to change it to radians, we just go back to the toolbar and click on radians. The radians is about 0.25. Let's recall from before on the next triangle, the square root of 63 is also the same thing as 3 square root 7. The reference angle is A again, so the opposite side will be the side with the square root. The longest side is the hypotenuse, and then the other side next to it is the adjacent. Sine of A is opposite over hypotenuse, 3 square root 7 over 12. Those can simplify, divide each by 3, you get square root 7 over 4. Cosine of A is adjacent over hypotenuse, 9 over 12. That simplifies to 3 over 4. Tangent is opposite over adjacent, 3 square root 7 over 9. That reduces to square root 7 over 3. Cosecant of A is hypotenuse over opposite, also known as the reciprocal of sine, 4 over square root 7. Rationalize them. You get 4 square root 7 over 7. Secant of A is hypotenuse over adjacent, also known as the reciprocal of cosine, 4 over 3. Cotangent of A, the reciprocal of tangent, adjacent over opposite. And then we have 3 over square root 7. Rationalize those. We get 3 square root 7 over 7. To find the approximate value for A, you can use any of these trig functions here. Let's use cosine this time. arc cosine of 3/4. Let's go ahead and put this into Desmos. Type in arc cosine of 3/4. And then you get about 41.4 degrees and then 0.72 radians. The square root of 65 does not simplify since that is 5 times 13, both numbers that don't have perfect squares in them. Our reference angle is A again. So the opposite is 7. The hypotenuse is the longest side, and the adjacent's the other side. Sine of A would be 7 over square root of 65. Rationalize those. And you get 7 square root of 65 over 65. Cosine of A, adjacent over hypotenuse, 4 over square root of 65. That also needs to be rationalized. 4 square root of 65 over 65. Tangent is opposite over adjacent, 7 over 4. Cosecant, we would have square root of 65 over 7. Secant would be square root of 65 over 4. And cotangent of A would be 4 over 7. To find the approximate value for A, let's go ahead and just do arc tangent of 7 over 4, which is about 60.3 degrees or 1.05 radians. Now, instead of arc tangent, you could do sine, for example. So if we did arc sine, we would have to use the other values. 4 over square root of 65, 7 over square root of 65, and then if we wanted to do cosine, it would be 4 over square root of 65. Notice they give you the same answer for all of those trig expressions. Let's go to the next page. We have a triangle, a right triangle, but we don't know what the third side is. So we can use Pythagorean theorem to find that. Remember, Pythagorean theorem is a squared plus b squared equals c squared. 4 squared plus 3 squared equals something squared. 16 plus 9 equals 25. The square root of 25 is 5. So that would be our missing side length. From there, we can find each of these trig values. Remember, sine is opposite over hypotenuse. The opposite reference angle is this theta. So this is the opposite. Longest side is hypotenuse, and then the other side is the adjacent. So that means that's going to be 4 over 5. Cosine was adjacent over hypotenuse. 3 over 5. Tangent was opposite over adjacent. 4 over 3. Cosecant is hypotenuse over opposite. 5 over 4. Secant is hypotenuse over adjacent. 5 over 3. And then cotangent is adjacent over opposite. 3 over 4. To find the value of theta, let's do arc sine of 4 over 5. Again, you can use the other trig expressions as well. Okay, we have about 53.1 degrees or 0.93 radians. All right, let's find the other missing side length here. We don't know what the opposite is. So we have a squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. Subtract the 144. The square root of 25 is 5. So it's 5 again in this case. All right, pause the video and try to find each of these values. And then evaluate the angle. Are these the values you calculated? All right, try the next one. We have all three side lengths, and our reference angle is theta again. Let's label these. Pause the video and try to evaluate each of these trig functions. Are these the values that you calculated? Remember, you can use arc, sine, cosine, tangent, etc. All right, same thing for these next two. Go ahead, pause the video, label your opposite, hypotenuse, and adjacent sides, and evaluate each expression. Also notice that on this example, the reference angle is now B, so the opposite side is going to be 7. Adjacent, and the hypotenuse is the longest side. Are these the numbers that you calculated? All right, try the next one. Find this missing side for side length AC. Use the Pythagorean theorem. Label the opposite, adjacent, hypotenuse sides, and then evaluate for each of these expressions. Are these the values that you found? Let's look at the next one. We have A's and B's instead of numbers in this one. Let's look at this. Sine of arc's tangent of B over A. By the way, this is the same thing as arc tan. Tangent is opposite over adjacent. So that means that B has to be the opposite in this case. And A is the adjacent. Sine is opposite over hypotenuse. Hypotenuse is the longest side. So that means that sine of this value right here is going to be B over the square root of A squared plus B squared. On this one, we have cosine of arc tangent of A over B. Well, in this case, A has to be opposite and B is adjacent. And the longest side is still the hypotenuse. Cosine is adjacent over hypotenuse, so that's B over the square root of a squared plus b squared again. And in this one, we have tangent of arctangent. When we have a tangent and we have an arctangent, they cancel out. And we're just left with b over the square root of a squared plus b squared. Now notice we had three different expressions, but they all simplified to become the same thing. Let's look at the last page. Converting from degrees to radians and radians to degrees. So to get radians, you take the degrees and multiply it by pi and divide by 180. The zeros cancel. 3 over 8t is the same thing as 1 over 6. So our radians would be pi over 6. 45 over 180. We could divide both of these by 45, and that gives you pi over 4. 60 over 180. You could divide those by 60. Pi over 3. 90 also can be divided by 180. We'll have pi over 2. 150 over 180. We divide both of those by 30. 5 pi over 6. 210 divided by 180. We divide those by 30. 7 pi over 6. 225 divided by 180. Let's divide those by 45s. Then we have 5 pi over 4. 240 divided by 180. Let's divide these by 60. 4 pi over 3. 300 divided by 180. Let's also divide those by 60. 5 pi over 3. And 315 divided by 180. Divide these by 45. It will give you 7 pi over 4. All right, now we're going to convert from radians to degrees. To get degrees, we multiply the radians times 180 and divide by pi. All right, so this is going to cancel, and 180 divided by 12 is 15. All right, pi over 6. 180 over pi, the pi's cancel. And that gives us 30 degrees. Pi over 4. 45 degrees. Pi over 3. 60 degrees. Pi over 2. 90 degrees. 2 pi over 3 would be 120 degrees. 135 degrees. Pi would just be 180. 270 degrees, and then 2 pi would be 360. Now, if you look at the unit circle at the bottom of this page, you can map each of these radians and degrees to it. Oh, except for the pi over 12. Sometimes they will show up on the unit circles. For example, we have 30 degrees is pi over 6. Those go together. We have pi over 2 is 90. Those go together, and so on.